Looking at a graph of the Earth's temperature, we can see that it has been anything but steady. Global warming from human emissions of carbon dioxide is supposed to be heating our planet. So why did the Earth cool for about 30 years following World War II? And why have temperatures appeared to drop since 1998? Is the whole man-made global warming thing totally wrong? Or are scientists just evil masterminds out to control us? Or are there more factors affecting the Earth's temperature than just carbon dioxide? Imagine Earth as a box, which people are pushing from opposite sides. They cancel each other out to some degree. But eventually, the stronger side wins and the box moves. The Earth's temperature is just like that. Some factors push on the Earth to warm, and some push on it to cool. Some of these factors are short-term and cyclical. From year to year, they can make a big difference in the Earth's temperature, but on a long-term scale, they generally balance out. The Sun, which follows 11-year sunspot cycles, can either push on the Earth to warm or to cool, depending on where it is in the cycle. El Niño, a change in Pacific Ocean currents every 4 to 7 years, temporarily pushes on the Earth to warm. It alternates with La Niña, the opposite phenomenon, which pushes on the Earth to cool. Additionally, a certain percentage of sunlight is reflected by the Earth's surface or atmosphere and is never absorbed by the planet. This percentage can increase with deforestation, clouds, and aerosols, particles suspended in the atmosphere from pollution or volcanoes. This phenomenon, sometimes known as global dimming, pushes on the Earth to cool. Finally, greenhouse gases such as carbon dioxide, methane, halocarbons, and water vapor trap heat in the atmosphere, which pushes on the Earth to warm. All of these factors affect the Earth's temperature, and most of them have some inherent variability. However, since the last ice age, the Earth has never moved in one direction very far or for very long. That is, until humans started increasing the amounts of greenhouse gases in the atmosphere. Through fossil fuel burning in cars, furnaces, and factories, as well as deforestation, we've increased atmospheric carbon dioxide by about 40%. Through agricultural practices and decomposing garbage, we've increased methane by about 150%. We've also introduced halocarbons, synthetic greenhouse gases which were never before present in the atmosphere. This additional warming force from anthropogenic greenhouse gases is the single largest persistent force on the Earth's temperature. And it's starting to show. The Earth is moving in the direction of warming faster than it possibly could from natural variability alone. However, forces other than greenhouse gases continue to go up and down. So if you only look at a few years of the Earth's temperature, it might look like global warming has stopped.
It's important to not read too much into a single cool year globally, or even a series of cool years globally. Certainly, a cool year or two does not mean that global warming has somehow stopped. What it means is that there's something in the climate system that has temporarily brought down the global temperature. 2008 was a very good example of that. There was a very strong La Nina condition in the Pacific Ocean in 2008, and it brought down the global temperature quite substantially. But it certainly in no way means that global warming has stopped. The underlying reasons for global warming are always in the background, but they can be temporarily masked by internal climate variability.
1998 had an exceptionally strong El Niño, so the following years looked cool in comparison, even though they were still above average. And if a cooling force persists, it can temporarily overpower greenhouse gases. Following World War II, there were a lot of aerosols in the atmosphere from post-war pollution, as well as more volcanoes than usual. Soon pollution began to be regulated, so greenhouse gases took over once again.
Climate variability and climate change are two different things. Climate variability is year to year or perhaps even decade to decade changes in the average global temperature, largely associated with the El Niño cycle, occasionally associated with volcanic eruptions, and to some degree with the sunspot cycle. But this short-term variability is not climate change. Climate change is the long-term change in the average global temperature, which is temporarily masked by changes, short-term changes associated with climate variability.
It's important to distinguish between noise, or normal short-term variations in the Earth's temperature, and trends, which are long-term average changes. And if we look at a longer reconstruction of temperature, such as the past millennium or so, the recent trend is even more obvious. Scientists don't expect every consecutive year to be warmer than the last. So in the short term, it's anyone's game. But in the long term, greenhouse gases are evidently winning, and the Earth is warming. Because humans are pushing too hard on one side of